Now today we will be seeing about the properties of air. So properties of air, which is very important topic. The other name for this one is also called psychrometry. Today we will be discussing in detail what is a psychrometry, how this psychrometry is very important in HVAC systems. So what are the different levels of psychrometry, what are the types, what are involved, and analyzing the psychrometry charts. What is a psychrometry chart? How we need to find dew point temperatures and those kind of stuff. Guys, today I am going to say you psychrometry is also a very important topic which you might be having learned in your engineering colleges and all. I want to say you, I want to recollect these things in a different manner, in a technical manner, and as well as in a practical approach, how you are going to implement in your design considerations. So let me go through the topic fully. So this here you can see it's just nothing but in properties of moist air. So moist air, the moist air is combination of dry air plus water vapor. You are already aware of that. If you are adding some water vapor to dry air, it is called in moist air. So these all physical properties are analyzed with the humidity levels as well as enthalpy, temperatures, just like you see how to measure the dry bulb temperature as well as wet bulb temperature. You might be knowing one without the wick, the moist cotton around the bulb, and other without that thing. So what basically you are going to measure? So the measuring is the temperature of air, the temperature of air. So you can see here, this is a chart related to dry bulb temperature. This is the bottom one. You can see the temperature, the dry bulb temperature. The dry bulb temperature, how we can take the dry bulb temperature measurement? So I want to say the dry bulb temperature, if you take a thermometer, the red bulb, bottom side of red bulb, without wrapping any cotton, what I should say, the moisture, to measure the temperature of air, you are not going to wound any moist cotton around the bulb. So if you are taking with that way, just swirling, so just like an swirling means moving the hand by keeping thermometer, so you can take the temperature. That temperature is called dry bulb temperature. This is the temperature of air you are measuring. So in these lines you can see the vertical lines 35, 40, you can, as you can say, see here 35, 40, 50, 60, like that it is increasing. So as you go down like this temperature is going to increase. This is nothing but the lines frame of formation of lines. So with various intervals of measurements we have taken. So guys, so similar way you can understand the sensible heat of air, the quantity of heat that can be measured by a dry bulb. This is also another way of expression of dry bulb. So what is the wet bulb temperature? WBT, that is WB. When an air is fully saturated, okay, so saturated means almost the moisture level has been completely accumulated. If you take a volume of air, when it is fully saturated, all the temperature of the dry bulb, wet bulb, the dew point will be having same thing. See, suppose I can take an example. Suppose you are measuring, how we are going to measure the wet bulb temperature. Take a thermometer, you try to wrap a wet cloth around the bulb and moist cloth, and try to take the temperature from the air. Okay, so you will be having the temperature which will be lower than the dry bulb temperature. This temperature is called dry bulb temperature. You can see the diagram here. So these are the lines for the wet bulb temperature. and wet bulb and dry bulb temperature is equal at this saturated point. This is the line called saturation line. Whenever the point is lying on this one, so you can say that the line is saturated, that point is saturated. So saturation point is nothing but 100% relative humidity. So coming to other one, that is the dew point temperature. Suppose if you are going to cool the air at a constant pressure, I mean, suppose you are taking some quantity of air and you are going to cool the air with a constant pressure, then the water which is present inside the particular air sample you have taken start condensing. So the temperature at which the water starts converting into the air starts converting into liquid is called a dew point temperature. At that particular temperature, the water vapor which is present in the air start condensing or converting into water. That is the point. So you have to understand, at constant pressure the air would start condensing from vapor to liquid. Okay, so these are the lines you can see here. These are the lines, horizontal lines. So this is the saturation line. Okay, so coming to this one, another one, humidity ratio. Humidity ratio is also going to play a very important role in the designing of HVAC systems. So humidity ratios can also be expressed as weight of water vapor per kg of dry air per pound of dry air. If you take 1 kg of air, so how much water vapor is present, or the granules, number of grains which is present, is called a humidity ratio. So number of grains present per kg of dry air, I can say in this manner. So that is called humidity ratios. Suppose you guys, you try to understand. Suppose I am having 12 by 12 and 8 feet, a kind of a room. So I want to find how much of the humidity ratio or number of grains or moisture particles present in that particular room. We can find out with the humidity ratio. So you can see here, this is the vertical lines here, 0 and 0.2, 0.4, 0.6, like this it is going to see here. Here itself you can see the definition. Humidity ratio is pounds of moisture per pound of dry air. Okay, so we'll go to next one. Relative humidity. Another name of the relative humidity is also RH. So you can see the lines actually moving from down like this. A curved fashion manner. You can see here curved fashion manner. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So I already said you the 100% line is saturation line. So you can see here, this is a saturation line. So you can have the definition also. It is defined as a ratio of actual water vapor in a given volume. If you take how much of weight of water vapor is present in a X volume to that of weight of water vapor contained in the same volume and at the same temperature when the air is saturated. So you try to understand the definition. It is unsaturated to saturated. Okay. So this is called relative humidity. We will go to another one, the specific volume. So specific volume, that is volume of air per unit dry of air. See, that is feet cube per LB dry air also we can say. That's a specific volume, the unit weight of dry air present. Okay. So this also lines you can see here. This is a cross lines here. You can see here. Like this it will come. So 12.5, 13, 13 like that it is there. This some slanting kind of there. So try to understand this one. Coming to enthalpy, the heat content, that is nothing but again a heat content enthalpy of air per unit weight. So if we are taking unit weight of air, what is the heat content present? That is BTU, British Thermal Unit per the LB of drain air. So here you can see here, this is the line, you can see charts. Guys, I am telling you, I have actually splitted the charts in a specific different separately, because if you can see the chart complete with all merging lines, you are not going to understand these things. So what I did is I simply separated all the things, and I want to show you in a easy manner so that you can understand very nicely. So I have given a separate chart, and you have to understand that psychrometric chart is a representation of all combination of these things. See here, I want to show you another things, how our heating and cooling conditions are being processed by using the psychrometric chart, and you can analyze in how the directions are also being moved up and down and across manners. See, I want to say you that in our air conditioning process, it is an cooling and dehumidification. Cooling and dehumidification basically. So what is called dehumidification? Dehumidification is the removing of moisture from the particular space. See, I want to show you this process in this chart here. So when I already explained you 0, 10, 20, 30, 40. If you are going in this direction, the temperature is going to increase. So if you are going in this direction, temperature is getting decreased. So let me show you this direction. So I want to reduce the temperature. So I am going in this direction. This is cooling. So another one, I want to do dehumidification. See, my dehumidification. Suppose I am starting from here. So this area, you can see the chart like this, it is going. You can see the chart here. I want to see here 10, 20, 30, 40, 50, 60, 70, it is trying to increase. The humidity levels is increasing from down to the top. So again, if you see here, my process is cooling and dehumidification. So I am going down here. See, dehumidification, removing of the water vapor and moisture and cooling. So this process is called our cooling. Our air conditioners, split ACs and commercial complexes where and all we are having the HVAC systems, this is the process that basically is happening. So if you go to foreign countries, guys, see, you have to understand, in foreign countries the temperature is very low outside. So I want to supply heat to the space. So there we are going to heat. So heating the temperature going this side. So like this I am going here. So you can see the process here. Heating and humidification. So here the heating process is increasing like this, and humidification process. So humidification, I am going to increase the humidity like this, because this is the order in which the increase of humidity is happening. So heating as well as humidification. I want to show you one more thing here. See, suppose you want to work in a textile industries. What is the process? You know here. So there are lot of dust particles which are going to fly around the space. So those flying particles we need to restrict by adding some of the humidity to the existing space so that they don't fly. So here in the textile industries, the humidification process to increase the weight of the lightweight particles which may be very harmful for the people's working. So we need to increase the weight of the particular dust particles or cotton particles. So we increase the humidity here as well as we do the cooling. So humidification is cooling, the process is inside the textile factories. So you have to understand these things very carefully and technically. So you can see here, this is a contact factor and bypass factor. Contact factor is defined as the portion of air passing through the coil that touches the coil. Suppose you can see the coil, you can see a radiator coil or any cooling coil. When we are going to blow air through the coil, if air is passing through the coil and touching the surface of a coil where the refrigerant is going, so it is called contact factor, and thus it is cool. Bypass factor, some air which will bypass actually, means it is not touching the coil and it will jump without touching the cooling coil. It is called bypass factor, and contact factor and bypass factor is always 1. So I think you have understood